How's everybody doing?
Yeah.
All right, so this year we all also doing something a little new. If you can't hear us quite well, there's a QR code in the back by the entrance that allows you to connect to the app, I think, and you can hear us the audio live stream through your phone. So that's also an option if you can't hear us quite well. All right. With that said, let's get started.
Yeah.
All right. Hi, everybody. I am David Lee. I am a senior product manager at Microsoft Visual Studio. I work on game developer workflows.
And I'm Michael Price, also a product manager working with David to help make Visual Studio the best developer experience for game devs. So this talk is about accelerating your inner loop, right? And when we talk about inner loop, we're really talking about three components. We're talking about coding, building, and debugging. We're going to have some features to show and some great demos in each of these categories. So we're going to go real briefly. We're going to kind of look at what's on the agenda here. I don't have a clicker, so you're going to have to click. Okay. So for coding, we're going to talk about how you can directly edit Unreal projects directly in Visual Studio. And we're going to show you how you can integrate GitHub Copilot in your workflow to really accelerate your coding process. Then we're going to talk about how you can slash your build times, in some cases very dramatically, using a tool that we have in Visual Studio called Build Insights. And then we're going to show you some debugging features, some things to make debugging faster, and then a really brand new feature we're going to talk about later.
So let's get started by sharing a little bit about what productivity means to us, the Visual Studio team. So over the past years, we got a lot of great feedback from developers. And out of those feedback, we have been focused on building tools into Visual Studio that allows you to stay on task, allow you to focus on what matters, which is building your game. Our philosophy is to continue to build tools, not only based on your feedback, but also to streamline your inner loop, make it more smooth every year. So to get started, let me share a little bit about what we've been working on for Unreal Engine integration. In the latest version of Visual Studio, you can now open Unreal Engine projects directly. So no more relying on VCXproj or the solution files that you're so used to. Starting now, you can directly open your U project from Visual Studio so that you don't have to run UBT or any of the Unreal tools every time you want to make a file change. Of course, with this new project format, there is a better experience for IntelliSense, something that we have heard a lot in feedback. So when you're using this mode, you'll receive a much faster and accurate IntelliSense. And lastly, for console developers, Xbox GDK will have a support update in June to introduce uProject for your dev kits. We have also dramatically streamlined our Unreal Engine plugin, the Visual Studio integration tool. You can now directly install this plugin from the configuration page in Visual Studio. The tool is open source on GitHub. For those of you who are using our Unreal Engine test adapter, running the plugin in background will give a good performance boost. But we have also heard feedback about wanting an easier access to the blueprint references within Visual Studio. So now, you can see your blueprint references without this tool. And very soon, we'll be removing this tool from the Fab Marketplace since you can directly install it in Visual Studio. Perhaps our biggest update yet is our blueprint debugger. When you're debugging an Unreal Engine game, you'll be able to see your blueprints in the call stack. Not only that, you'll be able to see your blueprint informations, so you can do the C++ conversion, see the information, and reiterate without having to jump back to the Unreal Engine editor so frequently. So that was our Unreal Engine update over the last year.
So let's talk some about GitHub Copilot. Anybody, any GitHub Copilot users in the audience? Oh, love to see it. So, GitHub Copilot, we introduced it last year at GDC. We talked about it. We talked about a lot of the a lot of the basic features that are in it, like GitHub Copilot Chat, lets you have a conversation sort of with the AI model. Next slide. And then we also talked about the GitHub Copilot completions, which are basically editor suggestions. As you're typing your code, it says, well, I see what code you've written, I see what's around, I see the context, and here's what I think you are going to write next. We've got some great new features, though, this year. And what we want to talk about here is making it easier to get started. And we want to introduce a new, very powerful editing feature called Copilot Edits. We want you to know that we've been working hard to actually make Copilot generate better results for the C++ users. So our team's been working really closely with GitHub to improve those models. And then lastly, we want to talk some about the ways you can customize GitHub Copilot to fit your environment. Now, this QR code here will take you to a getting started thing. Don't worry, it's going to go away, but it'll come back at the very last slide, so you don't have to rush and take a picture of it now. You'll be able to get to it later.
So we prepared a demo for everyone, and just to give to set the stage. Imagine your studio is having a hackathon this week, and whoever comes up with the most creative solution to your game will get added to the upcoming April Fool's updates. Something really fun for everybody. But because this is a hackathon, every minute counts. So let me show you how you can use GitHub Copilot to get quickly started with prototyping some edits to your game. So one of the first things that we can see in Visual Studio is the GitHub Copilot icon. With a button, you can press it and check whether your subscription is active, have interactions with Copilot-related settings, and of course, manage your Copilot subscription. So very quickly, now everyone can try Copilot as long as you have a GitHub account. So what you see here is custom instructions that we have added last year. We got a lot of feedback about how everyone wants to make Copilot more customizable. You can now add a special custom instructions markdown file in your GitHub folder, and GitHub Copilot will follow these instructions when it responds to you. For example, I have listed me and Michael as subject matter experts. Of course, remember, you can check this in, so anyone in your studio responding to Copilot will know who the subject matter experts. So perhaps there's one person that's really good with shaders. This would be a great place to put their name. Something I find myself doing quite a lot previous to this updates is I kept telling Copilot to be more and more concise. Well, this is something you can also do in the custom instructions. You can tell Copilot to be brief, get to the point, or maybe the other way around. You want more reasoning out of Copilot before digesting the information. So last year, we showed you 3 different places that you can interact with Copilot: through comments, through inline, and the Copilot chat window. This year, we have added a new way for you to interact with Copilot, and that is Copilot Edits. So in Copilot Edits, this is an AI-focused editing session. Remember last year we used Copilot Chat to come up with some code suggestions. But with Copilot Edits, you can separate your references, your understanding of code prompts to a coding-focused session. Now, remember, we're still doing this hackathon, right? We want to come up with a creative solution. So why don't we change the color of the character to a random color every time they move? with Copilot edits, it'll look through all your references. So this could be your documents that are open inside the IDE. Then it'll give you a plan of action along with the specific files that it has found to edit. So for example, I see 3 references that Copilot edits has shown me, and a game plan. The game plan to add a method to generate a random color. Okay, that makes sense. And then modify the movement function so the color gets applied every time the movement function is called. Great, I think this is a pretty good place to start. So as you can see here, one of the first suggestions is to add some header files. Okay, that makes sense. Can press tab to accept. Next, a helper function in on-movement mode change. Great, this is exactly what Copilot told me in the edits window. Let's press tab to accept. And our last helper function, change color to random in the CPP file. Doing a very quick scan through, okay, we have a mesh component, and then we're coming up with a way to make a random color. Okay, sure, let's see how this works. So right away you see some squigglies. That's because we haven't edited the header file yet. We can navigate to the header file and insert this declaration of the helper function. So void, change color to random. All right. Okay. Now let's see how we can further iterate on the snippet that Copilot has generated for us. So we all like logs and documentation. Why don't we just add some here? We can ask Copilot to come up with a logging function that see if the color has been applied. Okay, you write the comments, and Copilot will come up with this code suggestion for you. This seems reasonable enough. UE log color changed. Great. Now let's ask Copilot to print out the colors when it's been applied. Okay, so we once again write a comment, and then Copilot will come up with a suggestion. Something new this year is instead of outright accepting the suggestion, you can press the Alt and / key to enter the edit mode for the suggestion. You'll have a div, and then inside this interface, you can make edits to whatever code that Copilot has suggested before you press accept. So I change it from warning to log. All right. We still have some squigglies. Let's look around to figure out what could be the issue. So on the side, it says add a particular include. Okay, maybe this is relevant. Probably not, since we should know what UE log is. We're already in an Unreal Engine project. Once we hover over it, okay, identifier random color is undefined. So keep in mind, Copilot is there to help you rapidly prototype your changes, but it is up to you to verify the changes as been suggested. So of course, we initialize random color inside an if statement. So to fix this issue, we can just pull the second log statement into the if statement. So when the if statement is called and the color has been generated, we print that out to UE log. All right. With the changes to this function, so we hear a lot of feedback about wanting to document your code more, right? How many out there has made a code comment or document, let's say in the past 30 days. There should be more of you. Everyone should be documenting code, right? But with Copilot, documentation has gotten a lot easier. So not only can you jump around your code, you can inspect any symbol, click the Describe with Copilot button, and Copilot will feed a description to you. And you can, if you document this, it will also show up. But besides the Describe with Copilot function, we have gotten some feedback about the various actions with Copilot and how you want to keep that context and continuing to interact with it. So let's go up to our set movement, on movement mode change. Remember, we added this helper function earlier. So, like before, we can describe with Copilot. It gives us a description. Okay, great. It knew the current change. Then we can press the Continue in Chat window. So this will then open up a new Copilot chat window that you can continue to interact with Copilot this way. Here, I'm using the @workspace command to reference my entire workspace, right? I'm asking Copilot specifically within the confines of my Unreal Engine projects of how our new function change color to random, how in other places is being used similarly. Now keep in mind that because we're looking through our whole code base, Copilot could spend some additional time. It does really scale with how big your code base is. And in our example, we all know how big Unreal Engine is. So it will generate a response giving you the various references inside your code base and give you an answer. How change color to random is used currently in movement mode, and then give you some additional contexts. Then you can continue to ask follow-up questions. For example, here, what if I don't want to just change it to any random color, but instead have a specific set of colors to be randomized? You can click the follow-up question, and Copilot will continue your conversation within this context and give you some ideas on how you can change the colors to specific preset. You can see here, once again, with the @workspace command, we're referencing our whole code base. Some other things you can do if you didn't want to reference your whole code base. For example, you can highlight lines and use the hash lines, functions, files, documents. You can really scope in your particular reference points when you're interacting with Copilot. All right, it looks like Copilot has suggested a bunch of F-linear, there's just switch statements. Okay, that kind of makes sense. So let's continue the demo. This year, we have added the / command for full documentation. So once again, there should be no more excuses for not documenting your code. With /, you'll open up a summary as well as describe your parameters. And when you hover over the quick info in Visual Studio, you can see your documents has now been applied in the quick window, quick info pop-up. Okay, let's continue the demo by showing you one of the last ways that you can interact with Copilot. We got a lot of feedback about wanting to choose your different models, wanting to customize Copilot even more, and we're happy to share you can choose this particular model you want to interact with, from O1, O3 Mini, to even Cloud 3.7. The choice is in your hands. So with the @GitHub command, you can talk, ask questions from the web within Visual Studio. Why don't we ask GitHub, let's see, what are some of the best updates in Unreal Engine 5.5? And we'll try this with the GPT-4o model. So it knows what UE is, it knows your context, but most importantly, you're now talking and asking questions with the context of the web. It gives us some quick bullet points. Okay, now let's compare our answers with the O3 Mini. Perhaps you want more reasoning, or maybe you want to choose another model with more speed. The choice is in your hands. So as you can see here, I think the response is about the same, but different models will give you different responses. So that ends our GitHub Copilot demo.
So if there was anything new that you learned about Copilot, raise your hand. Good. That's what we want. So the thing that I want everybody to take is that it literally takes maybe 5 keystrokes to document your functions. 5. That's it. Doesn't matter how big your function is. 5 and 3 of them are the same key. So use that, please. So we want to highlight here at the end. One of the things I said, we want to remove blockers to get people started, right? And David mentioned that you can use GitHub Copilot free, which is a new offering we debuted at the beginning of the year. It's like a rate limited sort of solution, but you only need a GitHub account. If you have a GitHub account, you already have access to GitHub Copilot free. Okay. So some other things we want to pull out, right? This works with all source control, right? It doesn't matter if your source code for your game is in GitHub. It doesn't need to be in GitHub. You just need a GitHub account, right? But you can be running your repo with anything else, and it still works. If your company is worried about like exposing sensitive information, source code, assets, other things like that, your organization can actually set content exclusion filters that make sure that information, those files never get sent across the wire, right? So this way you can go to your bosses and be able to look, they have mechanisms in here to make sure our stuff doesn't leak. And again, you can try GitHub Copilot free with that one click using that GitHub Copilot badge in the upper right-hand corner of Visual Studio.
Great. So we chatted about Copilot edits, the newest way of interacting with Copilots, because this is your focused editing session in Visual Studio. We also shared various ways that Copilot can help you understand your code with Describe with Copilot. You can generate your formatted comments. The // it doesn't have to be in this particular Doxygen format. You get to choose if you have a particular formatting for documentation. And of course, we want to give you more choices of how to customize GitHub Copilot, with choosing different models to setting custom instructions. Once again, the choice is in your hands. So now let's move on to the build portion with slashing build times with build insights. Last year at GDC, we showed you a quick overview of how you can use build insights, particularly to include files. So maybe you're including files that is dramatically impacting your build time to expensive function generation times. This year, we're back with an update with the template instantiations. We want to share this tool has had great success with our partners at Activision. Recently, we worked alongside Xbox Advanced Technology Group to cut down Call of Duty Modern Warfare's build time by over 50%. It started at 28 minutes all the way down to 14 minutes. With the use of Build Insights, both Xbox and Activision were able to work together to trim the build times down. So imagine how much time you're saving each iteration. For more information, we have a detailed case study that we have published yesterday. Please go to aka.ms/buildinsightsmw2. We've had a lot of great detailed explanations of how they were able to dive into the code and come up with a solution that was able to cut down 14 minutes of their build time. We have the QR code that links to the blog, but don't worry, all the QR codes will be at the end in case you miss it.
All right, let's do another demo. This one's going to be live, so please send the right incantations into the universe. All right, let's try this one. Feedback, maybe this one. Okay, everybody can see this, right? Okay, so what I have here is I have a small solution that's just got a couple of projects in it. And these projects are just using templates in a way that may not be ideal for your build times. So we're going to use Build Insights to analyze this and then apply some fixes to them. Okay, so the first thing I'm going to do is I'm going to get a baseline. So I'm going to go do build, run Build Insights on solution, rebuild. I don't want to play any games. There's nothing already built. We're going to redo it from scratch. So last year, we showed you how you could use other parts of Build Insights to identify problems. We didn't focus, we've added a templates view since then, and we're going to focus on the templates view this time. So ETL file, which is going to have all the information about what happened, shows up. And we can see on the templates tab, it will load up. So our build took 8.5 seconds. And we can see that there are a couple of things that are kind of causing the dominating the build time in this, right? So I'm going to use this new project filtering quality of life tool or feature that we added to just filter it down to just one project at a time so I can focus on that. So I'm going to look at Sphene expected. So there's this TL : expected template that's taking up 6 seconds. It's a massive amount of time for my build, okay? So I want to go find out what that thing is. I'm going to use our all-in-one search capability, and I'm going to do a code search, and this is a type. Actually, I'm going to use a search for a file, F, so I'm going to use F : to scope it down to only look at files, and then expected.hpp. Okay, this is the one I'm looking for here. And you can see I don't even have to open the file. I get a nice preview of what this thing is. And you can see that this is an implementation of the standard expected type, written by one of our coworkers, Cybran. But it was written back in 2017 before this was actually in the standard and implemented by any of the standard libraries. So I know exactly what I'm going to do for this. I'm going to adopt the standard library version and see if it speeds it up. I'm going to close that. And let's go back to the other project. Okay, so this one's still taking up several seconds of time, and it's called @impl. This is a project that's actually, this type is actually like a type list indexing. So if you've got a template meta program with types, you can kind of find which index you want to get at. You can see that it's actually a nested instantiation. So you can see whenever you instantiate this, it's actually instantiating all of these other types, right? There's a couple of techniques that you can use. I'm going to show you one of them that we can then use to do it. So I'm going to go ahead and I'm going to switch to a branch on which I already have these changes made. And I'm going to go ahead and do a run Build Insights rebuild on that. And while that's happening, I'm going to actually show you what those changes look like. Git diff main. Oh, my mouse messed up here. Git diff. the surface that the mouse is on is sloped, and so my mouse is slowly sliding down. Okay. So this is the type list indexing. So the thing that's the problem here that's causing all of the issues, not that way, there we go, is this nested inheritance that's happening right here. So we nested inheritance and we're instantiating each one in the level of nesting inheritance. There's a better way to do this, which is to actually just do a parameter unpack and just inherit from all of them all at once, right? So you can see we use this technique here on this line, and that should be a lot better. And then at the end, you can see I'm just swapping out the custom implementation of that expected type for the standard one that we provide in the standard library. Okay, so let's go see what that actually did to our build times. Okay, so we can see in the old build, it took 8.5 seconds effectively, and the new build took 4 seconds. So we cut our build time in half. There's just very small, very precise changes to 2 templates. Now, these are just 2 source files that were doing this, but templates get used in a lot of source files, right? And so you're going to incur that cost every source file that you do those things in. So you can imagine over hundreds and hundreds of source files you're doing this, you're shaving a couple of seconds off of each one. You're going to end up saving minutes every build that you do. And that's really going to speed up or accelerate your iteration time in your inner loop. And that's a demo. And I'll say too, if you're, I've seen a couple people get up already. If you're considering leaving, wait, because our last demo is our best one. It's the one you're going to be talking about later.
All right, so we shared some of the latest updates and build insights with the new templates view that allows you to diagnose costly template instantiations. We have also added a variety of quality of life improvements that allows you to filter your projects, some adjustments to the columns. So give you some additional nice touches here whenever you're interacting with ETL files that Build Insights generates. Now let's continue with our last portion, the debug section.
Yeah, so we're going to talk some about conditional breakpoints first. Anybody ever use conditional breakpoints? They're awesome, right? So you use these things, you set a breakpoint, but you say, I only want to break on this whenever some condition is true, like there's a particular asset being displayed on the screen, right? So this way you don't break with an asset is displayed, it's that particular one. So let's talk about this. So whenever you set a conditional breakpoint, there's overhead that happens, right? Because the debugger, it has to check whether the condition is true before it decides whether to break or not. So in the latest versions of Visual Studio, what we've done is we've greatly reduced the cost of this overhead, right? In fact, we reduced it. It's now over 2.5 times faster than what it was before. In our tests with 80,000 iterations, what took 80 seconds before now takes 30 seconds. Right? So this is really going to speed up your debug cycles if you're using those conditional breakpoints.
Yeah, and although we didn't get to show in the demo, next time you're setting up conditional breakpoints, look for that sparkly icon so you can let Copilot to suggest some conditions for you.
Yeah.
Now let's talk about optimized builds. So over the past few years, I chatted with a lot of game developers out there. I think there's one thing that keeps coming up again and again and again. A particular wish about being able to debug your optimized builds. We all know currently this is not possible, right? Because you either add things in and you rebuild and that costs iteration time, or you just use your debug build and you have 1 or 2 frames. There's not really anything in between. So we want to introduce you our latest and biggest updates to our C++ debugger. It's called C++ Dynamic Debugging.
So, like who all has ever seen this in their locals or their watch window? Variable is optimized away, right? This means you're running in an optimized build. Sorry, The compiler generated code that's not going to let you see what the value of that thing is because you want to go fast, right? You don't care about debugging. You want to go fast. So how do you fix this usually? Use registers. Okay, make sure the calling conventions using registers. Okay, another way that people typically will do it is they'll go back to their source code. They'll add pragma optimize off in their source code. They'll rebuild and then rerun like get back to the program to the state it needs to be. That takes a lot of time, right? Well, with this new feature, you don't have to do that anymore, right? Just forget that, right? You don't have to worry about accidentally checking it in and messing everybody else's code up, right? Like you won't have to do that anymore.
We have been working with our AAA partners at Xbox to make sure this feature is extremely useful for production games.
So, for instance, Jess from the coalition said the new feature is exceptional. They have access to all the normal debugging stuff that you normally have if you have de-optimized code. You can do step operations. You can see where the current program counter is at. All those things without having to recompile.
Our friends at Rare have discovered a new ability to actually step into force inline functions, something that just was not possible before.
And Halo Studios, they said it improved their ability to debug and investigate quicker. And again, that's our point, right? We're accelerating your inner loop. We want you to get back to writing your game faster than you could before.
So I guess the question is, when can I use this, right? You can use it now. Right now, if you update your Visual Studio and your compiler, you'll be able to use this right now in Visual Studio 2022, version 17.14, Preview 2. Now, to show you all this in action, we have prepared a demo for you. As you can see here, I have the editor open, and I am using the Lara game. As you can see here, my frames are 60. Shift F1. And the game is running, and I have full frames. Now keep in mind, this is a fully optimized game running at full frames 60 that I set it to. So we're in Visual Studio. Let's activate this breakpoint. Right away, Visual Studio will break on this piece of rendering code. The first thing that you want to check out when you're using C++ dynamic debugging is to go to the call stack window. As you can see here, I have a de-optimized frame. This indicator, this tag, will show you when you're debugging an optimized build exactly what frames are being de-optimized. Because we're dynamically de-optimizing particular frames that you want to inspect and leaving the rest optimized so it does not impact your game performance. Now let's do some debugging actions that you just previously weren't able to do. Remember step into? How many of you have used step into on an optimized build? And what's usually the result of stepping? It goes random places. You can never predict where it will land, right? If we click step into, Visual Studio will now automatically de-optimize this particular section of code. A force inline function, something that was just, you couldn't see this before. Now let's step out and step into our next function. Once again, previously, these pieces of code are just not able to you're just not able to access it because they were optimized away. We can press F10 a few times to step through the code. So you can see here, all of my locos are visible because you are in a particular frame that has already been de-optimized. What else can we do? We can go to a particular line, right-click, and set next statement. This is something you definitely couldn't do before. If we set next statement, the program will automatically run that statement. You can also, for example, run to cursor. Okay, now let's step out of this function. So what Visual Studio does is, what we do is now we're building two copies of your game, one optimized and one unoptimized. And at debug time, we're able to swap the frames so that you're only looking at the optimized frames. And out of performance, we don't just de-optimize everything. If we go into this function, let's say, okay, so here we have a familiar variable is optimized away. But with C++ dynamic debugging, you can now de-optimize that on your next entry into this frame. You can highlight just that one or all the frames above, right-click, have de-optimize on next entry, and when we press F5, all these frames will be de-optimized. If we click on that frame, you'll see scene. You can now see scene instead of being optimized away. And all of these breakpoints are stored under a breakpoint group. Whenever you're done with debugging this piece of code, you can select all of these, delete them. I will uncheck that, hit continue, and we're back in our game with full FPS.
So David, does the frames per second matter whenever you're actually in the debugging session and broken? It doesn't, right? Because like you're broke, right? You don't need to. You're not worrying about the frames per second when you're actually debugging the thing, right? When you're done, it's back to full frames.
So we have a lot of details of how you can get us up and working. We have a very detailed blog, how you can set this up on your C++ projects. You can go to aka.ms/dynamic debugging. And of course, we have the QR code at the end as well.
Yeah. So I mean, as David showed, right now you don't have to do this variable is optimized away thing anymore. You build it with this setting on, and whenever you debug, your stuff's going to be there, right? So you can see the before and after. One is not usable. The other one is incredibly helpful, right? And then you'll also be able to do all the normal debugging stuff that if you're not worried about frame rates and that sort of stuff, like all the stuff anybody could do, you can now do in your game, right? You're no longer blocked off from those sets of features.
So obviously, there's some considerations. Previously, I've mentioned that Visual Studio will be building your PDBs and your binaries twice. So there is some impact on file output size, as well as some iteration build time impacts. Now, with all these considerations, I do want to reiterate that you no longer have to rebuild your project every time you want to de-optimize a particular function. So overall, we're highly confident that your overall iteration time will be dramatically decreased. In our blog, we do have some additional mitigations for those of you are running large monolithic builds. And of course, we're listening to your feedback to continue to improve this feature. Currently, this is only available on x64 architecture, and it does not support link time code generation, profile guided optimization, opt-ICF, and incremental linking. For our console developers, you'll be able to use this with your Xbox GDK coming up in the April updates. Incredible 1023, 1024, actually, the newest, will have full support for C++ dynamic debugging. We're also working with the FastBuild team, so if you do run FastBuild in-house, we have a PR ready. You can find out more in our blog. And lastly, for all Unreal Engine developers, coming up in UE 5.6, C++ dynamic debugging will be natively supported for both UBT as well as Unreal Build Accelerator.
Yeah, so that's our talk, right? We hope that you'll be able to take this stuff and just run with it and make your inner loops as fast as can be. We're going to keep working on it on our end as well. So to do that, like we rely on your feedback. Like you tell us what the problems are, and then we go solve those problems, right? So now's a great time if you need to take QR pictures of the QR codes. If you have questions that you want us to answer, if we don't get to all of them, let's see how much time we have. We have about 13 minutes. But yeah, we'll be available in the Xbox Lounge that's in the South Hall on the right outside where registration was. We'll be there from 2 to 3 to answer any of the questions that we don't get to right now. Thanks for coming to the talk. Who's going to try dynamic debugging tonight? I would if I hadn't already known what it was. I would definitely be trying it. So any questions? Raise your hand if you have questions, and we'll run a mic out to you. Oh, yes. Also, we have Eric here, who is the dev lead on this. So if you want to pick his brain about how this works, now is a good time to do it. Any questions, please? We have 13 minutes.
How many of you get a chance to talk to the Visual Studio team, like you were, while you're at home and you're like shaking your fist at your screen, like this is the chance to ask a question?
Yeah, something's not working right. Now's a chance. Yeah. Well,
if you have tickets, you know who to send them to.
Yeah. Okay. Well, if you change your mind, there's a couple of business cards up here with contact information. You can grab one on your way out. If you think of something later, feel free to shoot us an email or contact us anyway. Again, come visit us at the Xbox Lounge. There's a lot more stuff going at the Xbox Lounge than just us. I know that we're the real show here, but Clint, what else is happening in the Xbox Lounge?
So in the Xbox Lounge, we have experts across all of our GDK, our services. If you're applying to ID at Xbox, so publishing, development, anywhere, wherever you're at in the process, right? Wherever you're at in your journey, we might have an expert in the lounge. And if we don't have someone there at the moment, we can pull someone in, or we can ask someone to meet you on the following day. So we're there all week. We'll also have, we may ask our Visual Studio team to come visit us again at the lounge. So any questions you have, please stop by.
All right. Thanks, everybody.
Thanks.